All right, welcome to testing inferences about means. How this is different than the last section that we did is this is dealing with actual values, not percentages. We're looking at the average, say, weight of a person, the average, size or length of something, as opposed to just simply looking at percents. What you'll notice though is if you understood the last section that we did on percents, you did the projects on percents. This and any other type of hypothesis test is very similar. Really what you're doing is you're running through a specific set of conditions. They will change depending on what test you have. For those of you that took a biology course, you might have run into a thing called a chi-square test. They have their own set of conditions. They all have different conditions, but the same idea is you want to get down to a p-value, which you use a computer or calculator, and then be able to analyze things later. So these are the conditions we're talking about means. So it needs to be a random sample, just like always. We need to know the value of the standard deviation. So we're going to talk about a different scenario in the next section. But right now, we're going to assume we know the standard deviation. And the population is normally distributed or the sample size greater than 30. So when you go to do your projects, I know that's far away because you just looked at this. When you go to do the projects, pick an NBA sport, go state by state analysis, just make sure the sample size is greater than 30, and you don't have to worry about dealing with normally distributed work. If it's less than 30, you really need to make sure that there's somewhat of a normal distribution. It doesn't have to be perfect, but a majority of this data should be in the middle with few on the outside. So let's take a look real quick at a sample problem. So this one we're looking at the weights of M&Ms. So pause the video for a second, read through the problem, and then we will move from here. So what you're trying to do here is you're trying to determine whether or not these M&Ms weigh too much. If they weigh too much, the bag weighs too much, we're losing money, and so on. So what we're trying to do in this example is determine if the weight's greater than the 0.8535 or not. Again, we're talking 4 decimal places, 3 or 4 decimal places down here. We're not going to be exact with this, but we still want to determine this. So let's run through our conditions first. Because right now what we did is we took a sample. We took a sample of 13 M&Ms, and we're assuming we sampled the M&Ms at random. We know, because the candy company told us that the deviation is 0.0565 grams. That's a standard deviation. And we looked at a sample of 13. And just real quick, what I did is I put this on a spreadsheet. I went here, and if you just click here and order them, you'll notice that a majority of them are 0.8. There's a few 0.7s, a few 0.9. So this would classify as normally distributed. So I could say just some simple statement. We looked at a sample 13 and it's normally distributed. The second part is, what are we trying to test? So I think what we're trying to test here is, do we need the weights to be 0.8535 grams? So really our null and our alternate hypothesis, if I flash down here, the null and alternate is, we're told it should be 0.8535. We took a sample as 0.8635. Is that really significantly different? So this is the hypothesis. And then over here, again, just indicate what type of test you're running. So you might want to include something like that. Okay, we were running the test at a 5% significance. Now, the mechanics for this, okay, and I left this blank with the mechanics and inclusion because the mechanics really come down to using some sort of technology. So you could go to, say, like a website like this. Like what I did is I just, Google searched hypothesis testing mean deviation known calculator, came up with this website, and you can plug in the information there. One of the downsides to doing this is typically you will have to go onto a spreadsheet like this, equals average. You'll have to put your information here and find out what the average is. Now, in this problem, I gave it to you, but if you're doing your own information, you're going to have to calculate that average somehow. One of the advantages of these TI calculators, if you still have one from your high school days and you still, or have access to one, is if you hit stat edit and put this information in a list, it will really do everything else for you. Once you go to stat, go over to calculate, or sorry, tests. And what we're doing here is what they call a z-test. And if you leave it on data and you're testing down here, 0.8535, and you just fill in your information here, and what I did is I just kind of jumped ahead and put the information. So your null hypothesis 0.8535, you're going to use the data that you put in. It's list L1, you put in the standard deviation. We want to show that it's greater because ours was 0.8635 from the problem. We want to show it's greater. Then you hit the calculate button. This is what they're looking for, and you notice here it gives you a p-value of 0.27. So you would then, what you're going to want to do is copy this information into a document. So if you look here, what I did is just copied it, and you would want to take all this information and put it into this. And make sure you indicate everything in there on your mechanics. So I'm just going to put a ... assuming you handwrite it or take a picture, whatever. And the main thing that we're looking for is the p-value here is 0.27. And what that tells us again is the probability of this happening is about 27%. So even though our M&Ms were greater than the 0.8535, they weren't significantly greater. Anything less than 5%, we're going to define as significance, just like we did before. That's why we're running it at 5% significance. And here we got a p-value of 0.27. So our conclusion would look something like this. And there you go. So since our p-value is not less than 5%, we're going to fail to reject the null hypothesis. The M&M's weights are not different what they should be, and since the p-value is not near 5%, it's unlikely we made an error in our decision. If this p-value was something like 0.06, about 6%, it is possible if we sample another set of M&M's, we might get a p-value, say 4%, and then have a different conclusion. Since this is not near there, we can say it's unlikely that we made an error in our decision. So if you take a look at this, you notice it's not much different. Hopefully you can understand that this is a pretty direct way to go. I'm going to share another video to do another sample problem, then let you run on your own. But hopefully you should be good to go at this point. And good luck, and let me know what questions you may have.